Okay, hello again. This time we're going to be graphing a quadratic sequence. And the sequence is 3, 4, 6, 9, 13. So I didn't give it to you in terms of term n this time, where you had to work out the actual values of the terms. Instead, I gave them to you. So what we would do before we would graph, in this case, though, if they give you these and they don't tell you that it is a sequence of a particular type and you can't recognize it by looking at it, I would check the first and second differences just to make sure. So again, we'll do that here. 3 to 4 is 1, 4 to 6 is 2, 6 to 9 is 3, 9 to 13 is 4, and the second difference 1, 1, 1. So it's definitely quadratic, isn't it? Quadratic. Now, since you have graphed quadratic functions before, you know what a quadratic function looks like when it's graphed. It is either this form, a parabola, a U-shaped parabola, or this form, an N-shaped parabola. Now, the thing though with these particular graphing sequences, and because we don't have like term -1 or term -2, and we're usually using only this side of the graph, we don't often see a full parabola in our drawing. We often just see a part of one. So we might see this kind of a shape because it's like this side of the U shape, or it might be this kind of a shape because it's like this side of an N shape. So don't be worried if when you're graphing these later on you don't get a full U shape or you don't get a full N shape, because that usually quite often doesn't happen when we're graphing these patterns. More often than not, I'd say it doesn't happen. So just to speed things along, I drew the axes here again, and notice that the term goes on the bottom, so term 1, 2, 3, 4, 5, and the value then goes up on the side, and we can see the highest value is 13, so I've gone up as far as 13 here in the top. So again, we just need to plot the points, and we treat them like coordinate geometry. So this is, if you like, the point 1, 3. So plotting this point, term 1, 3, and again, it would be preferable to be using graph paper if you have it, and definitely using a ruler if you don't. But because I'm holding this camera, it's making it more difficult. So next one is 2, 4. So term 2, 4 here. 3, 6, 3, 6. In fact, I might just do the rest of them by putting down the camera, because I'd say I'm already going askew. I'll just pause for a second. Okay, so there I've just plotted those points. Now I would say that one or two of these could move a little bit because again, as I was holding the camera at the very start, I didn't plot them the very best that they could have been plotted. But after having plotted the points, I suppose the first thing to notice is I have to plot all of the points when it's quadratic. I can't take a shortcut and plot the first one and the last one, because then you have no idea of the curve you're drawing. Okay, so you can only take that shortcut when it comes to linear graphs that you're drawing. And then we can see, first of all, that it is the graph is curving in this direction. So we think it's probably this part of a U-shaped type of graph. And so we do freehand as best as we can, keeping it kind of curved, try not to introduce any corners to it, you know, like if you're drawing, try not to go like this and then kind of jerk like that where we have little dips. Now mine is just so badly done because I'm trying to do it with one hand. I'm sure you'll make a much better effort yourself when you're trying this later. So again, this is the sequence that we were asked to graph. Value on this side, terms down on this side, curved shape. It should be a portion of a parabola, either a portion of a U-shaped or an N-shaped parabola.